Welcome to Digital and FinTech Analytics channel.
Then finally, we have something known as NDCG. What is NDCG? NDCG basically stands for Normalized Discounted Cumulative Gain, and it's a metric that is used to evaluate the quality of ranked list or recommendations, taking into account both the relevance of the items and their positions in the list. So, so what NDCG basically does, if you have to look into the formula of NDCG, it's a very complicated formula. This one is a very complicated formula, but I will give you an intuition of like how does NDCG works. So by now you might have understood from the definition of NDCG that it says how well the items are ranked. So suppose we are ranking like 10 items to user 1. Okay. We are recommending 10 items to user 1. So are those 10 items ranked in such a way that by seeing the initial few items, the user is like more likely to click on the initial few items as compared to the later few items? Because say like the later few items are recommended, but that is not more likely that the user is going to purchase. And say like we are recommending those items in the number one position and these items in the last position. So the user will lose his or her interest in purchasing after looking into few of the items that have been suggested initially, but that are like not more likely that the user is propelled to click on it. But these items that have been suggested, if ranked well, then the items that have been suggested in rank 1 or like rank 1, 2, 3, 4, 5, then the user is more likely to click on that. So let's try to understand this one with the help of this formula. This is a very intuitive explanation of this formula. So if you see like this formula, there is one interesting part which is known as, which we also call it as discounting factor, which is like this 1 by log k. So 1 by log k. Let's plot this formula to understand what is the importance of this formula. So if you plot that particular formula, so 1 by log k, where I'm just taking the x values as some values from 1 to 11, and 1 by log k is what we are plotting over here. Yeah. So if you see this 1 by log k, and if I take a snapshot of this, so what does this formula says is like the items that appear in initial positions are like given more scores. Okay. And the items that appear later in the positions, like say like after 10th, ninth, and 8th, then these items are given very less score, say something around zero point 0.3, zero point 0.5. And the item that are initially appearing, so those items are like given like high score values. So that's how NDCG works. So the items that are initially present are like given like more values as compared to the items that are like later present in the prediction list. So yeah, so I was talking about this discounting technique, right? So discounting is a technique used to reduce the importance or weight of items as their position in the list increases. In the context of like the ranking metrics like NDCG, it reflects the intuition that items appearing higher in the list are generally more or relevant are more important or relevant to the user than those appearing lower in the list. So here we are using like the logarithmic discount that I was just talking about, and it says like as k or like the as x values increases, the value of like the log 2x also increases, but at a decreasing rate due to the logarithmic nature of the function. And dividing 1 by this value ensures that the discounting effect increases as the position of the item in the list increases, but at a decreasing rate. So that's what I explained over there right now. So that's how like NDCG works. And we are also calculating the NDCG using the same formula that I was just showing it over here. I've coded it up in this part, and we are passing the actuals and predictions, and it is giving us the NDCG value for each of the users in the test data set. Finally, what we are doing is like we are calculating the average recall value, average NDCG value, and average PHR value across all the users in the test data set. So for that, we just call that particular column and get the mean of that particular column for recall. Similarly for NDCG value also. And for PHR value,
We will sum up all the ones, or in other word, we will get the count of all the users who have at least one item overlap between the actuals and the prediction, or the actuals and the ground truth data, divided by the total number of items that we have in the test data set.
so here we get the average recall, average NDCG, and average PHR value.
Since this is a very computationally expensive task, hence it is being run on a very small subset of users in the dataset. But if you have a very good configuration laptop, or you are running on a very high configuration cluster in the cloud, you can run it over all the users in the dataset. So currently we are running it over just 100 users in the dataset, but
So we have around 3,881 users in the test data. To just perform this task over all the 3,881 user, you just need to remove like this head of 100. These two things, if you remove, then you are good to go.
with this piece of code removed, you can run it over all the users in the test dataset. And after that, you will see that the average PHR, NDCG, and average recall value will be higher than what we are currently getting. This method gives pretty much close to the state of the art results in recommendation systems.
There is a paper named as like the next basket recommendation reality check. The link to this paper I will put it in the description of this video. Please go through it. It is a very interesting read. And that's all for next basket recommendation system. Thank you. Hope you had a very great learning over here. You can use this as a very good backend project or a data science project in your resume. Thank you. That's a wrap for today's video. If you found this content valuable, make sure to hit that like button and subscribe to the channel so you don't miss out on future insights into data science, AI, machine learning, and analytics. Looking to master data science or drive data driven success? I offer expert training, mentorship, and consultancy for individuals and organizations. Let's collaborate. Reach out via my contact details in the bio.